Thank you for tuning in our ELEC 1 final project presentation. Our robotic arm have extremely fast processing time. Grabbing 3 marshmallows only requires 2.3 seconds. Now, let's see it in 0.1 speed. As we can see, the operation is smooth and no overshoot. The two main arms of the robot are 15 cm and 23 cm respectively. All the motors are completely integrated into the structure to minimize footprint. The design ensures minimum working volume. The electronic side consists of a Arduino Leonardo microcontroller, a 93% efficiency 10-amp AC to DC power converter, a custom-designed PWM motor driver. The system have a working efficiency above 85%, all compactly assembled into a 4x13 by 15 cm box. Let's review all the RCGs. With 3.5 degrees of freedom, our robot can access any position at any angle in a defined 2D workspace. Zero overshoot when grabbing the marshmallows, and is able to discard defective product to a garbage chute 10 cm away. Materials used in this build strictly complies with the provided supplier. Our robot have a minimum processing time of 2.3 seconds for 3 objects, minimum cost, component footprint, working volume, and power requirement. The process of designing is not smooth at all times. The most frequently used debugging tools will be signal monitors from MATLAB, Multisim, and Simulation X. As we can see from the Simulation X data log, the motor angle did not follow the desired path, and something is wrong. Many additional simulations are performed to test out partial system performance before moving on. For example, the behavior of the inverse kinematic is first tested out in our MATLAB multibody simulation. You can see we are trying to draw a rectangle here. The parallel design of our robot allows powerful motors to be placed at the base. This ensures the arm is strong and light, which allows fast movement and agility. All the joints are connected by bearings to ensure minimum friction. To implement the homing function, 3 limit switches are used. To increase the compactness of the design, motors and arms are connected using timing belts. All high force and torque components are connected to a sturdy base, which ensures rigidity and stability. The claw is open and closed using a small lightweight motor. Speed reduction is achieved by using worm gear, which saves the cost and weight of additional gear heads. We choose H-bridge for its high power efficiency and fast response characteristic. The MOSFET used in this build have a power-on resistance of only 38 milliohms. 10-amp fuse is in place to prevent overload. Power LED is installed to indicate if the device is powered. Bypass capacitor is added to ensure smooth operation. Arduino is coupled to the H-bridge by photocoupler. This translates the 5-volt Arduino logic level signal to 12-volt signal that the H-bridge can use. It has the added benefit of noise isolation. The noise of the motor will not affect the operation of the microcontroller.
In Simulation X, we recreate the ARM model in SolidWorks by using CAD file instead of using simple shapes. We need to adjust the position of the CAD file using translation and rotation, which requires a lot of time and effort. We use context to simulate the parallel structure of the arm. After recreating the model, we also add the physical model and visual effects of the marshmallows. We use prismatic joints to simulate the movement of the marshmallow and use context to simulate the interaction between the claw and the marshmallows. Hence, the claw can grab the marshmallows and release them into the bin, which you can see in the video at the beginning.